Growth and decay model explanation. This equation tells us that the population grows at a rate that is proportional to the size of the population. Here, the population growth rate is how fast the population is growing at a certain time. In our equation, T is equal to the relative growth, P is equal to the size of a population at a given time, and if our population increases, the division of the derivatives will also increase proportionally.
So for our first step, we're going to multiply both sides by dt. We then go and divide by p. Then we integrate both sides. Where c is the general constant, then we raise them on both sides. Then, our logarithm is 1, so we only remain with p on the left side. Multiplication of exponents with the same base equals the sum of the exponents. E to the c is a constant, so we can replace it with c. Multiplication is equal to equation 1.
When t equals to 0, k times 0 is equal to 0 and e to the 0 is equal to 1. So the initial population P0 is equal to c. We get a final equation where the population is equal to the initial population P0 multiplied by e raised to k times t, which are the relative growth rate and time. When we substitute t with 0 in the equation, k times 0 is equal to 0 and e to the 0 is equal to 1. So we only remain with t. So P0, the initial population, is equal to c, the constant. Now we put all this into the first equation and we get that the population is equal to the initial population P0 multiplied by e raised to the k times t, which are the relative growth rate and time. Now we can use this formula to determine the size of a population in a specific time or predict the size of the population by replacing t with different values.